Thank you. So the next presentation is Shift2Rail OPTIMA. So Gabriele Ceccetti, yeah.
Okay. Hello to everybody, and thanks you for giving me the opportunity of presenting the Shift2Rail OPTIMA project, which is I am myself, and I am a researcher of Scuola Superiore Sant'Anna, and here are on behalf of the OPTIMA Consortium, and I am a technical leader of this project. Next slide, please. I want just to give you some context about how this project is born. As you know, the infrastructure manager use the traffic management system to control operation about the traffic, energy, and any systems that have on their infrastructure. The problem with the current systems, the current limitation is that each country has different traffic management system, and inside the same country can coexist different ones. And different systems use different standards in communications, and there is a lack of standardization between the data exchanges, the data structure used. So, to overcome these limitations, the Shift2Rail is trying to implement new technology for traffic management system that have the goal to create standardized frameworks. Merci. Standardized frameworks, new interoperable data structure, messaging system that are in real times, and the standardized communication infrastructures. So next slide, please. So the Shift2Rail want to create the Shift2Rail joint undertaking as thinking to set up a technological demonstrator that they call technological demonstrator 2.9. And this demonstrator should be implemented by the OPTIMA project. That's as a goal to demonstrate, to create a demonstrator which is based on a standard communication platform that uses standardized data structure, and let an interoperable exchanges of information between the different systems that are linked to this communication bus. Next slide. So this can be achievable following these three technical objectives. The first one is creating an integration layer that's allow the communication. The second one is specifying a common data model that will be used to define a common data structure to exchange messages, and then standardizing all the building blocks of the workflow. So using a standardized operator workstation, and more than this, using an application framework where you can deploy the application of a traffic management system in a plug and play manner. Next slide, please. And so the OPTIMA demonstrator will enable new application for traffic management and traffic control, and will enable the integration of new functionality that are developed also in other Shift2Rail projects, and will allow the integration of new technologies and functionalities, like, for example, functionality for ATO, for moving block, and so on. And in the next slide, next slide please. I'm going to show you what are the general architecture of the optimal projects. The core is in the middle where you have the bus that is the integration layer, which is API and its common data model. Then on the bottom, from the left to the right, you have the rail business service that can be interlocking system, RBC, maintenance service, energy management system. Each of these services is connected by its own legacy protocol, for example, in C4 proprietary protocol, to a client that is developed in software and is able to talk with this field infrastructure. And then there is a translation service that are the interface service, and these services are able to send the information to the integration layer. This exchanging information happens between a publish-subscribe protocol, and this led to have a very scalable system. Not only in this scenario, we can also add the external service, like for example, a weather forecast or a passenger information system. As well, the operator workstation that are inside the control center. And on the top, you will have the application framework where there are the traffic management service. For example, the applications that are managing the interlocking or the RBC. So the next slide. The core of this system is this integration layer. That's in the case of the Optima project has been implemented by using RTI DDS, which is a commercial variant of OpenDDS protocol. And in the Optima, we have just added the integration layer API that integrate. Next slide, please. That integrate the Optima requirements and can connect in a seamless way the existing signaling infrastructure and enable the access to the external application. The integration layer APIs has various services that let the various operations to be run in easy way, like authentication, authorization, transaction, and logging service, and so on. And then, next slide. The other core component is the common data model. This model guarantees the interoperability between the different data sources and system application, and it allows the integration of legacy and future applications in just one communication structure. The data definition depends on business requirements, and this work has been conducted by UEC in collaboration with Shift2Rail for complementary projects. The outcome is a platform-specific models that is implemented inside the Optima project. If we see in the next slide, yes, from the top left, you see that you start with a requirement that can come from Excel file or UML diagram or XML sheet. And with this, you have the CDM definition that usually define a platform independent model. This platform independent model have to be translated in a platform-specific model, specific to the platform you are using, and this is possible with the tools that we are getting from Shift2Rail for project, and the outcome are a protobuf schema that go inside a codec library. This codec library is used by any software service or application, for example, live business service or application prototypes, and in this way, every application can communicate in a standardized way with the integration layer. So on the integration layer, you have the binary data structured according the CDN definition. And all the operations are coordinated by the integration layer service. Okay, the next one, another things that is important to notice is that how we get the data from the field. In the Optima project, we have 3 different operators, ADIF, RFI, and Sprava Selenix, that is the sex operator. We get the data from their track circuits. The data are collected on the infrastructure manager service. Then here, for regulatory issues, so we cannot be directly connected to them because for cybersecurity reasons. So we cannot get the data in real time, but we get the log files and we anonymize them. And then the data is elaborated from the different level of interface that parses the events coming from the infrastructure manager and play again this event on the integration layer, and so talk with the integration layer through the integration layer interface. If we look at the different at the next slides, one question that could you could wonder is how we deal with the 3 different infrastructure managers. Next slide, please. Because in Optima, we are using the railway lines that start from Ventimiglia and end in Albenga. And in this line, that is the Optima railway network, we have also to map the data coming from ADIF and from SEX Republic. So to do this, we add a further layer of software that is named in Optima one virtual track. So we are, for example, for the weather forecast that is taken from a station in Malaga, in Spain, we map this on this track, and that is done by software. So we are mixing the data coming from different infrastructure manager, just is one track. We do this just to demonstrate the interoperability of different data sources. Okay, the next slide. This is a typical configuration of the operator workstation that where the different application of the Optima projects are controlled. And for example, here you can see an application about the traffic management. And then in the next slide, I can show you what is the application framework. An application framework is a uniform environment where you can put your application inside virtual machine or containers. So each application is well isolated to the other, and they are in the control of the infrastructure manager. And all these applications use the standardized interfaces that are available on the integration layer. And so they can talk each to the other, and more important, with the field infrastructure in a standardized way. The access to this application is usually possible by the integration layer, but sometimes is also possible through the application framework REST API for some particular case where it's more convenient to use this. Also, the application framework lets a better life cycle to let the vendors to deploy the application inside the infrastructure management environment. In the next slide, we see quickly how this application framework is organized. We have in the data centers several servers with VMware software that lets you to manage different virtual machine and containers. And above here we have all the software that manage the integration layer APIs, the different service about interlocking RBC, maintenance service, and so on. On the bottom of them, they are accessing to the persistence layer where they hold all the log files. And still inside this environment, we'll have the TMS service that are still contained inside the virtual machine and containers. In the next slide, here you can see an example. On the right side, you see in the black part, on the top you see how the data is got from the legacy TMS. That should be some data about train position. And that is a legacy format that is coming from RFI and is written in Italian, for example, the position, the end, treno, and so on. And this data, of course, is not interoperable at all. Applying the transformation with the platform-specific models, this data is transformed in something that follow the CDM rules and in the JSON file. And here you can see the transformation in the JSON format. And this is shown here statically, but if you click on this slide, this is the continuous flow of an event that we are flowing on the integration layer. So there are thousands of messages that flow on integration layers that depends by the different events that are coming from the different sources. So now we are at the end. We go to the last slide. Currently, the Optima demonstrator is in the final stage of the development, and we should finish this development hopefully in a couple of months, and then we will start the validation activity. This validation activity will be integrated also by the external validation, because the prototypes that are currently developed in Shift2Rail Shift2Rail project will be connected to Optima integration layer, and so the Shift2Rail 4 prototypes will use the data coming from the field to the Optima, and they will use, more important, the same integration layer and their application, so the application of another project, will be interoperable with the data got from the Optima Rail Business Service. And that is possible because there are two key elements. One is the CDM, the Common Data Model, or as Pierre said, the conceptual data model. They are quite the same things. And the other is the integration layer. And if this joint collaboration will be successful, the Optima demonstrator will be the technological demonstrator TD 2.9 of Shift2Rail. This I have finished for this. Thank you to everyone. Thanks.